I am Anil Kumar. Welcome to my series on circle theorem. Let me thank all the viewers and subscribers for making some of my videos on this topic very popular. Now let's talk about all of them in this particular video. Here you see 5 diagrams. They relate to 5 important concepts. In the very first one, we are talking about 2 angles, one at the center, one on the circumference. And their relation is that if one on the circumference is theta, then the angle subtended at the center is twice that amount, 2 theta. Right? So that is the relation. Now in the second one, we are talking about angles which share the same arc. So this is the arc which both of them share. So if that is the case, then the angles on the circumference are both same. Correct? Now in the third diagram, what we really have is a diagonal. So in a semicircle, whenever you have a triangle inscribed in a circle, it will be at right angles, right? Now we have a very popular and very difficult concept sometimes to understand about the alternate angles. So if this angle here is, let us say, x, then the alternate angle will be this angle, and these angles are always equal, right? And the last here is about a quadrilateral. We call it cyclic quadrilateral, where the sum of these two is always 180. So if this is x, then the other one is 180 degrees minus x, right? So their sum is always 180 degrees, correct? So these are 5 very important concepts which we'll actually prove and then move forward and take some examples. So let's prove the very first one, which is prove that angle subtended by an arc at the center of the circle is twice the angle subtended at any point on the circumference, right? So here, let us do a construction. So what I will do here is I'll join this point with the vertex of that point, right? Now, let us say that the angles which we have for each triangle here are x and y. Let's say this is x and this is y. Now, since these angles are x and y, what is going to be that angle? Well, this angle total is 360. So this will be 360 degrees minus x and minus y. Perfect? Right. Now, let's look into the other angles in this particular figure. Here, you will notice that we are joined with center all these lines. So they are the radii and they must be equal. Since they are equal, both these triangles are isosceles. So what should be this angle? Well, this angle should be 180 minus x divided by 2, since these two are same angles, correct? They are equal angles. So that should be 180 degrees minus this angle divided by 2. Right? How about the other angle? Well, these two angles are also equal. And these two angles are 180 degrees minus this y divided by 2. Now, we are actually talking about what? We are talking about the complete angle at the circumference. How much should that be? Well, that should be sum of these two. So let me add them up. So we have 180 degrees minus x divided by 2 plus 180 degrees minus y divided by 2. So when you add them, they already have the same denominator, right? So it is 2. And we get 180 plus 180 as 360 degrees, right? And then we have minus x and we have minus y. So this is our angle at the vertex. Let's call this angle as theta. Correct? Now what do you notice? The angle at the center is 360 minus x minus y, the numerator. Do you see that? Perfect. So if I call that angle as phi, in that case I can see that this angle theta is half of the angle phi, which is at the center, because at the center we have 360 degrees minus x minus y, the numerator. Does it make sense? That is how we can easily prove it, correct? Now based on this, here is a very important conclusion. We need to prove that the angles in the same segment are equal. That means we are calling this, right? So this arc, you can say, right? Segment, if I join it, it forms a segment. So if they are equal, that really means that what? If I join, let's say if I form an angle here with these 2 points, right? So if I join these two, in that case, this angle should also be equal to the other angle, right? Or if I join it somewhere else, but the arc remains the same, in that case, this angle should also be the same angle, correct? So that angle should also be phi by 2, because this arc decides the angle at the center. Does it make sense to you? So all these angles will be phi by 2, half to the angle which this arc makes at the center. Does it make sense to you? Right? So that is how we get to this concept. Perfect. Now let's look into the third concept, which is we need to now prove that angle subtended by an arc at the circumference by a semicircle is a right angle. So if this is a semicircle, then the center lies on it. And we are trying to say that this angle here should be a right angle. Correct? That is what we want to prove. Well, you could actually draw the conclusion from the previous step. That is, we know this angle theta should be equal to phi divided by 2. And this is a straight line, so which is 180 degrees. So it has to be 180 degrees divided by 2, which is equal to 90 degrees. Well, that is one way to do it. The other way to do it is just as we proved the theorem itself earlier. So I'll do a construction here. I'll join these 2 points. So if I join these 2 points, I actually form 2 triangles, right? So let's say this angle is x for me and this angle is y. In that case, what is x plus y? X plus y is 180 degrees, right? Now, you realize that this is the radius, right? So that means we are talking about the triangle which is isosceles. Now, in this particular triangle, what should be this angle? This angle should be, since the sum of 3 angles is 180, it should be 180 degrees minus x divided by 2, since this angle is also equal to that angle, right? Okay, now on the other hand, what should be the angle in the other triangle? Now this angle is equal to the other angle, and both these angles should be how much? They should be 180 degrees minus y divided by 2, correct? And what is the sum of these two? Now we are talking about the sum of these two. So how do I get the sum? Let me add them up. So if I add this up and call this angle as theta, then my theta is equal to sum of these two, right? Which is 180 degrees minus x over 2 plus 180 degrees minus y over 2. Well, that is clearly equals to 180 plus 180, 360 degrees minus x minus y over 2, right? Or if I take them in bracket and make it positive, I could do that, right? Minus minus. Now if you open, you get the same thing. X plus y is 180 degrees, correct? Because it is the diameter. Since x plus y is 180 degrees, we could write this as 360 degrees minus 180 degrees over 2, or 180 degrees over 2, which gives you the expected 90 degrees. Do you see that? So you could actually prove it in this fashion, just as we proved the first theorem. I hope that makes sense, right? Let's move on and take the next theorem. Now this theorem is based on a cyclic quadrilateral, right? So we're talking now about a cyclic quadrilateral. Any quadrilateral inscribed in a circle with its vertices on the circle will be termed as cyclic quadrilateral. We need to prove that sum of opposite angles of a cyclic quadrilateral is 180 degrees. Well, let's find the center. Let's say this is the center of the circle, right? So let's join these lines with the center. Okay, now what do you get? We get two angles here. One is angle x. Now if this is the angle x, what should be that angle? Well, it should be, from our first theorem, x by 2. Correct? Right. Half of the angle at the center. Well, if this is y, what should you get for that angle? Well, this angle should be half of y. Right? So we are talking about sum of these two angles, right? So y by 2 plus we are looking into x by 2, right? So if I combine these two, what do I get? 2 as common, we get x plus y. But what is x plus y? Well, x plus y is the whole circle. Correct? So x plus y is the full circle, which is 360 degrees. So we know x plus y equals to 360 degrees. So I could replace x plus y with 360 degrees and divide it by 2 to get my answer, which is 180 degrees. Is that clear? So sum of opposite angles is always 180. For the other two, you can again do the same thing and get the result, right? So the construction will be on the other side. Is that clear? Right? So that is how we can prove all these theorems. And now let's get back to the most important theorem, and which really confuses many, is the alternate segment theorem. The alternate segment theorem states, let me first say the statement which we need to prove. Prove that the angles between a chord and the tangent is equal to the angle in the alternate segment. So we need to prove that this angle is equal to the angle in the alternates, this angle, right? So this is what we need to prove. Correct? Now, let us see how to prove it. Well, we'll need some construction to be done here. So what I will do here is, let's say we construct a diagonal from here. Okay. So let's say it goes through the center. Now, if this is the diagonal, and if I join that point here, I know what angle I get on the circumference with this new triangle formed. It is 90 degrees. Perfect? Yes. So we just proved that in a semicircle, the angle formed at the circumference is 90 degrees. Correct? So that is how we get this. Second, we also know that the angle between the radius and the tangent is 90 degrees, right? So this is between radius and tangent is 90 degrees. And this is semicircle. Is 90 degrees, right? Semicircle angle at circumference. Clear? So we know that. Now that should help us to prove that those two angles are equal. Okay, so what we are going to do now is we'll consider this particular triangle which we just constructed. Now if this is x, let us say, then how much should that be? That should be 90 degrees minus x, right? So this is 90 minus x, so what should be the other angle? Well, this is 90, that is minus x, so that should be x. You get an idea, right? So we get this angle equal to that angle. Well, we wanted to prove this particular angle, not that one. How do I prove that? Okay, what you also notice is that we have the same arc for both these angles. that is this angle, is we are talking about that segment. Do you see that? This angle is opposite to this segment. Now this arc is same for that angle also. So from here we prove that both these angles should be equal. You get an idea. So that is how we actually prove it. So what we did here was that we used the theorem, that is the angle subtended by the same arc are equal. Does it make sense? So that is the arc, this is the segment, and this is called the alternate segment. You understand now? Perfect. So how I visualize it when given a word problem or any diagram to figure out the angles, I shade the angle in which the tangent and the chord makes, and then I look at the angle opposite to the chord. So that is the easy way to do it. But I guess you have also understood the proof. So our proof included construction. So first step is construct a diagonal. Then we form a triangle. And then we know in that particular triangle we have 190 degrees. The other angle is 90 minus x. So this angle should be x. Now these two angles which we are talking about are across the same arc. They should be equal. So that is how you prove it. Perfect. So I think the first part is clear, how to prove our important theorems. Based on the concepts learned, here we have a couple of questions for you to practice. You can have a good look at it. These questions you can use calculator. We'll take a short break, enjoy the wildlife of Canada. Some beautiful birds are around. And then with a fresh mind, we'll solve these questions. Thank you. I hope you enjoyed the wildlife. This beautiful bird is called merganser, which visits us in March. And she will again visit us on her way back to south after 2 months. Okay, now let us see how to solve these questions. Here is question number 1. I hope most of you must have got the answer by now. Well, the calculator is allowed here. We'll also practice a bit of algebra. So that's the whole idea, right? So easy ones I've left, and I've taken real difficult ones here, which will give you good practice, just few of them. So question number 1 says, find the unknown angles. So we have 2 questions here, part A and B. So let me just draw a line here in between. Okay. So here we are given the 2 angles, which are 3x minus 5 degrees, this is this angle, 3x minus 5 degrees. The other one here is 2x plus 15 degrees. We need to find the three angles mentioned here. Now in this particular diagram, we have a diameter here, and then we are given two angles. We know at the circumference, on a semicircle, we'll get a 90 degrees angle. So that completes the diagram. That should help you to get the right answer. Okay, so here we know we have the same arc, correct? So since we have the same arc, both the angles mentioned must be equal, right? So they are against the same arc. So that is what you need to understand, right? Same arc. So that really means that these two angles are equal. So we can write 3x minus 5 equals to 2x plus 15. Bring x terms together. So we have 3x minus 2x equals to 15 plus 5, or we get x equals to 20. And the angles are in degrees. So we get the value of x. Now once you get the value of x, we need to substitute here and find each angle. Both will be same. So let's calculate with the first one. So we have 3 times 20 minus 5. That gives you 60 minus 5, or 55 degrees, right? So that is the value of this angle. So this angle is equal to 55 degrees. Just to check, let us do the calculation for the next one also. 2 times 20 plus 15 gives you 40 plus 15, and that is also 55 degrees, correct? So both angles are indeed 55 degrees. So that confirms what we just proved, right? Now from here, what should be the y value? This angle at the center is 2 times 55 degrees, and so it should be 110 degrees. Is that clear to you, right? So that is how you're going to solve this particular question. Now calculator is allowed, but in this particular question, the values were such that you could actually solve it without calculator much faster. I hope you must have realized it, right? Now in the second case, what are we looking at? We are looking at a semicircle, right? So semicircle. So that is what we are looking at. So as soon as you see semicircle, we know this is forming a 90 degrees angle. Now that helps to solve this particular question, right? So this really means that the value of 5x minus 12 plus 3x should be equal to 90 degrees, right? Since total is 180 degrees, other two angles should add up to 90 degrees. So that gives you 8x equals to 90 plus 12, which is how much? 2 and 10, 102. And that gives you the value of x as 102 divided by 8. Now this is where you should use calculator, right? So don't try it without calculator. So we get 102 divided by 8, which gives you the angle as equal to 12.75 degrees, right? If calculator is allowed, this is where you should use it. So we get our angle. Now we can find all the angles. So we say 3 times 12.75 is equal to how much? Let's multiply by 3 and get your answer in decimals. So we have 38.25. So this angle here is 38.25 degrees. The other angle, you could do the calculations, which is 12.75 minus 12. Let's do it. 5 times 12.75. And then we have to take away 12 to get our answer in decimals. It gives you 51.75, right? So the alternate method which I will prefer here to find the second angle is what? Is basically 90 degrees minus 38.25. That was faster, right? So if I check 90 minus 38.25, I get the same result, which is 51.75. Does it make sense to you? So in a test paper, you should prefer, while doing your calculations, once you find the easier one, then take away from 90 and find the other one, right? So that is a key. You have to save time at sometimes, right? Okay. Now let's take the second question here, which is based on the other theorems which we learned. The question here is, find the unknown angle. Well, this is 55, and we know this angle is the alternate angle, so it is 55. So we can write x equals to 55 degrees and y should be 40 degrees. Do you understand? So what we did was, since 55 is in this particular thing, so alternate segment is this one, opposite angle to alternate segment. In the other case, 40 is right here, right? So we are talking about this segment, and the alternate one is this one. So that is how we kind of link them. So if you see this diagram clearly, it should be not a problem always to get it very fast, right? Now let's do this. Now in this particular, we have a cyclic quadrilateral, right? So what did you learn about it? They add up to 180. So we can write 2x plus x plus 21 equals to 180, right? So that gives you 3x equals to 180 minus 21, or x is equal to 180 minus 21 divided by 3. So you could do without calculator, but again, since I said calculator is allowed, right? So 180 minus 21, say equal to, then divide by 3 and check the value. It is 53 degrees. So we get this as 53 degrees. Do you see that? So that is how we are going to find the value of x. Once you get the value of x, I'm going to multiply by 2, and so I get this angle as, so 2x equals to 2 times 53, which is equal to 106 degrees, correct? So the other angle, which is x plus 21, should be equal to how much? Well, I could do 180 minus this also and get my answer, correct? So 80 minus 6 is 74. The other angle is 53 plus 21, which is also 74 degrees. Do you see that? So either way we could have done it. So you could have also done this as 180 degrees minus 106 equals to 74 degrees. Does it make sense to you, right? So I have done 2 of these for you, and these 2 I'll leave it for you, right? So try to figure out this one, right? So solve this yourself. Their addition is also 180, right? So they also add to 180 degrees. So figure them out. So I'm leaving that for you to do, and write your answer in the comments. That'd be good. So I think you've done the questions, which gives you the insight to our theorem. Now here is what we learned. Question number 3 is, angle subtended by an arc at the center of a circle is what of the angle subtended at any point on the circumference? You need to fill in the gaps, right? Question 4, angle subtended by an arc at the circumference by a semicircle is a dash angle. Question 5, angles in the same segment are what? Question 6, sum of opposite angles of a cyclic quadrilateral is what? Question 7, the angle between a chord and tangent is equal to the angle in the which segment? So write down your answers for all of these questions. Take your time and then look into my solutions, right? So the very first one, angle subtended by an arc at the center of the circle is half or double the angle subtended at any point on the circumference. It is twice, right? Or you can say twice or double. Question 4, angle subtended by an arc at the circumference of a semicircle is a right angle. Question 5, angles in the same segment are equal. Question 6, sum of opposite angles of a cyclic quadrilateral is 180 degrees. The angles between the chord and the tangent is equal to the angle in the alternate segments. Is that clear? So with this we wind up, and I hope you understand all the concepts related to circle theorems, and you are now in a position to answer any question based on it. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.